Mrs. Arnold here, coming to you from my living room. Feeling a little better tonight, but with all of the sickness and stuff going around, I am going to go ahead and be gone tomorrow as well on Tuesday, just to make sure that it is finally gone and won't sneak up on me again. But I did hear that you had some difficulties with lesson 10 today, so I wanted to go over some of the examples that maybe the sub wasn't able to provide explanation or help you understand how to get to the root of the problem and be able to solve it. And then I'm going to create another quick little video for you so that you can work on Tuesday's lesson as well. So hopefully my dogs won't go crazy here in the background. They get a little feisty when they hear cars pulling down the gravel road. So hopefully they keep it to a minimum for us here. All right, so lesson 10 is all about order of operations. So this really is truly a review from stuff that we did at the beginning of the year, but then applying the new operations that you have learned since the beginning of the year, like incorporating our addition of fractions with unlike denominators or multiplying fractions. So we're going to review really quick that order of operations. I know I've told you many times that when we learn something in any grade level, but especially since we're focused on fifth grade this year, anytime we're learning something, it's not just for that moment. It is for our minds to take it, lock it away, and be able to pull it out and use it. So let's refresh our memories here. We have used GEMDAS. This should sound familiar to you. We have used GEMDAS to help us remember those different steps. And so let's go through and define each one of those. Sorry, I ran out of lead in my pencil and I'm trying to get the new lead to come out. All right, so we have our G. So G is for grouping. And that uses parentheses, braces, ooh, hello, and then brackets. So when we have this order of operations, we know G is for grouping, E is exponents, M and D multiplication, division, addition, subtraction. So this is the order that we evaluate everything. Well, this G, these grouping symbols, give us the opportunity that we can do things out of order. So if we needed to perform some kind of subtraction first prior to doing multiplication, then we could do that by using parentheses, braces, and brackets to separate those operations out from the others. And then it draws our eyes to them and we know that they have priority. So grouping allows for that order of operations to be pulled and used in a different order if needed. E is our exponents. Exponents we don't use a whole lot in fifth grade. This is going to be a big part of next year's learning in your sixth grade standards. So, but that exponent we have used with our powers of tens. So if I have 10 to the third power, my base number is 10 and my exponent is 3. The exponent tells me how many times I see this base number as a factor. So 10 to the third power, or 10 cubed, is going to be 10, my base number, as a factor. So I'm going to use multiplication, and I'm going to see 10 as a factor 3 times. So 10 times 10 times 10 is going to end up equaling 1,000. And so that exponent would work the same with any number. If it was 2 squared or 2 to the second power, that'd be 2 times 2, which is 4, and so forth and so on. Okay. Then we have our multiplication and division. So I'm going to do these together. So multiplication and division. I'm just going to write multiply and divide. They are equal level of operations. One is not more important than the other. And so we do these in whichever order they come in from left to right. So multiplication is not more important than divisions. We don't go look for multiplication and do that first. We don't go look for division first. We perform these two in order from left to right. And then our last two, the A and the S, are the same, except for these are going to be our addition and subtraction. And they are equal operations as well, so we are just going to perform those as we see them going left to right. Okay, so a couple things to remember. GEMDOS is built on a hierarchy. Remember that the grouping allows us to take operations and have them done in a different order. But from there, the rest of these all build on each other because they are a hierarchy. So addition and subtraction is just adding and subtracting those numbers. Multiplying and dividing is a more sophisticated way of adding and subtracting, and so they take priority over adding and subtracting. And then exponents is a more sophisticated way of doing multiplication, so it takes priority over just our plain old multiplying, and so then it also takes precedence over that addition and that subtraction. So this is really that hierarchy of operations that we follow in a normal number sentence. Okay. All right. So when we look at problem number 1, we can see that we have a tape diagram, and it's asking us to write expressions to match the diagrams and then evaluate. So problem number 1, I have a tape diagram. I know that this tape diagram has the value of 8 plus 9. I'm going to keep those numbers there because they want me to write an expression. And so when I write my expression, I'm going to use the original numbers that they provided me with. So my tape diagram is also split into thirds. And it's asking me to discover what the value of one of these thirds is. So I know that I need to know what 1/3 of the sum of 8 and 9. So this is where it's going to become really important for us to know all of those words that we might see when we're describing operations in words instead of symbols. So when I see 1/3 of the sum, that word of means multiplication. It could mean multiplication because we have groups of whole numbers. It could mean multiplication because we only want a portion of a number instead of the whole entire group. In this instance, we only want a portion. We want 1/3 of the sum of 8 and 9. Sum means addition. So I have 1/3 times 8 plus 9. Now, I can't just walk away from this because I have to remember that no matter what, number sentences always have an order of operation. And so if I were to just leave this as is, I'm taking 1/3 of 8 and then I'm going to add 9. That's not what this tape diagram is asking me to do. I need 1/3 of the sum of 8 and 9. So I have to find my sum of 8 and 9 first. So where addition is usually the last thing that is done, because I need 1/3 of that entire group, this is where I'm going to pull these parentheses in. I need this 8 and this 9 to be in a set of parentheses so that after I add those, I can take 1/3 of that whole entire number. So it does ask us to go ahead and evaluate. So we're going to go ahead. 8 plus 9 is 17. I can get rid of my parentheses and my addition sign, and I'm just going to pull down what is left over. So right now I have 1/3 times 17. I am going to go ahead and put that 17 over a 1, and I'm going to multiply across. Numerator times numerator, 1 times 17 is 17, and denominator times denominator, 3 times 1 is 3. So right now I have 17/3. 17/3 is going to be an improper fraction when our numerator is larger than our denominator. So I'm going to want to take groupings of 3/3 out of that 17/3. How many groups of 3/3 can I get out of there? Well, when I think about 3 and I think of my multiples, 15 is the closest I can get to 17 without going over. So if I want to take 15/3 out of here, 15/3 is also equivalent to 5 wholes. And then if I take 15/3 away from 17/3, I have 2 of those thirds left over. So 17/3 converts into a mixed number of 5 2/3. I can double check my work. If I'm saying my question mark is equal to 5 2/3, does that make sense? Well, I can plug it in right up here, and I can take a look really quickly. I have 3 groups of 5, which is 15. Then I have 2/3, 4/3, and 6/3. 6/3 is also equivalent to 2 wholes. So I have 2 wholes plus 15 for my 3 groups of 5. That gives me 17. And then when I look up here, 8 plus 9 is equal to 17. So yes, 5 2/3 makes a correct answer. All right, moving on, we have our next diagram. This next tape diagram is a hole. We don't know the value of this hole. That is our big question mark. Okay, what we do know is that this hole is broken into thirds. And we know the value of our thirds. Each third is worth 3/5 plus 1/2. So if I need to find the total here, I could look and I could say, okay, well, this is 3/5 plus 1/2 plus 3/5 plus 1/2 plus 3/5 plus 1/2. But that takes a really long time. And so I know that we have a more sophisticated way of doing that addition, and that comes with our multiplication. I have 3 groups of the sum 3/5 and 1/2. So essentially, that's what I'm going to be looking at. I have 3 groupings, and in each one of those groupings is 3/5 plus 1/2. So I can rewrite that as a number sentence. 3 groups of, I'm going to use that multiplication symbol. And then I want the sum of 3/5 and 1/2. So I'm going to insert that addition sign to show that I'm doing addition because of the word sum. And then again, just like above, I don't want 3 groups of 3/5. I want 3 groups of 3/5 and 1/2. So I'm going to have to think of my order of operations and know that in order to get that whole 3 groups of 3/5 plus 1/2, I have to put that addition inside of my parentheses. So I'm going to come over here and I'm going to work with 3/5 and 1/2. I have a 5 and a 2, so I know my lowest common denominator is going to be 10. So I have to go through that process of taking 3/5 and turning it into an equivalent fraction with 10 in the denominator. So how did I make this 5 become a 10? By multiplying it by the value of 2 over 2. So we get the value of 1. Anything times 1 is going to be itself. It's going to maintain its value, but give us new numbers that we can work better with. So 2 times 3 gives me a 6 in my denominator. And then over here, 1/2 changes into something with a 10 in the denominator. I'm going to multiply this by 5 over 5. So my new numerator is going to be 5. I'm going to add those parts together and get 11 tenths. 11 tenths is an improper fraction, so I need to remove 10 tenths out of there. When I take 10 tenths out, I'm going to get one whole and have 1 tenth left over. Now, I'm going to come over and use that information inside my parentheses here. Since I'm going to multiply it by the whole number 3, I'm going to go ahead and put that 3 over the denominator of 1. And I'm going to use my improper fraction because it's easier to multiply this improper fraction than it is to multiply this mixed number. So I'm going to bring over my 11 tenths. Now we're going to follow the same thing that we always do when we multiply fractions. Numerator times numerator, so 3 times 11 gives me 33. And then denominator times denominator, 1 times 10 is 10. So I have 33 tenths. Again, we have an improper fraction, so I'm going to take 33 tenths and I'm going to simplify that. 33 tenths simplified, I need to take out groupings of 10 tenths. I can take out 30 tenths. 30 tenths is going to give me the whole number 3. And then I'm going to have 3 of those tenths left over. So 3 and 3 tenths gives me the quantity of this whole. And we can again check our answer because we said each third was going to equal 1 and 1/10. So if we look there at 1 and 1/10, we can see we have 1, 2, 3 wholes plus 1, 2, 3 tenths. So 3 and 3 tenths is confirmed as our final answer. All right, so that wraps up number 1. Let's go down and let's take a look at problem 2. Problem 2 has several different parts to it. And it's asking you just to write an expression to match and then evaluate. So remember, an expression just means that we don't have an equal sign. So when we look back here, we can see we have just this number sentence. There's no equal sign on it. And just this number sentence here with no equal sign. When we evaluate, that's when we're going to want to start throwing those equal signs in. So when we look at 2a, 1/6 the sum. So let me set us up here. We have 1/6 the sum, 1/6 the sum of 16 and 20. 1/6 the sum of 16 and 20. Now we've talked about this before. Anytime we have a number outside of the parentheses, we know that it signifies multiplication, but we can also write that multiplication sign in as well. Now notice that I did put parentheses around 16 plus 20 because it's saying the sum of 16 and 20. So I need to get this sum first. It doesn't say 1/6 of 16 and then add 20 more. So we have to make sure that we're taking both of those numbers and we're adding those numbers together. So 16 plus 20 gives us 36. I'm going to go ahead and write that over 1 because I know that I want 1/6 of that sum. So I'm going to end up getting 1 times 36 is 36. And 6 times 1 gives me 6. So I have this improper fraction of 36/6. And we know 36 divided by 6 is going to end up giving us 6 wholes. All right, let's jump over to, let's see. Let's jump down here. 3. It says circle the expressions that give the same product as 4/5 times 7 and explain how you know. So you are going to want to evaluate 4/5 times 7 to see what that product is. And then you're going to be taking a look at the 5 expressions that they gave you, and I'm trying to, this is supposed to be its own expression. I'm not sure why they have that so close. So it's actually 6 expressions that they gave you. This one is one by itself. 7 divided by 5 times 4 is another one by itself, and then all the others are spread out nicely. So there's actually 6 expressions for you to choose from. So you're going to have to look and see how can you make sense of those to help you decide whether or not they are going to equal the same as 4/5 of 7. Number 4, you're solving each one of those, remembering the order of operations as you do it. And then you are going to be using your less than, greater than, or equal to symbol to be able to answer that. You can explain your thinking just off to the side there. It's asking you to do it without calculating. So if we were to look at 4a, we have 4 times 2 plus 4 times 2/3, and then we have 3 groups of 2/3. So when I see 3 times 2/3, I know right away that that answer is going to be less than 3, because I'm not going to have that whole group, right? I'm going to have 2/3 plus 2/3 plus 2/3. And when I get that, that's 6/3. And then when I look at 4 times 2 plus 4 times 2/3, well, I can see right away that 4 times 2 is going to give me 8 wholes. So I have 8 wholes no matter what here that I'm going to add some fractional amount to. Now, that is always going to be bigger than 3 times 2/3. So I didn't have to calculate this whole thing out. I could use reason, knowing that, hey, I'm going to have 8 wholes here. Over here, I'm not going to have 3 wholes even. So I know that 4 times 2 plus 4 times 2/3 is greater than 3 times 2/3. So they're wanting you to kind of use your sense of thinking. Remember, anytime we have a whole number times a fraction less than 1, the product is going to be smaller than that number. So for instance, when I say that, when we take 4 times 2/3, we know that our product is going to be smaller than 4, because in order for it to be 4 exactly, we'd have to multiply it by the value of 1, and 2/3 is less than 1. So we are not going to get this whole group of 4. Our product is actually going to be smaller than that. So we know that we're going to end up having 8/3. And when we look at 8/3, that converts over into 2 and 2/3. So our product is smaller than the whole number when we multiply it by a fraction less than 1. So they want you to kind of keep that in mind as you're working through here and you're looking at your different options. What do you see and what do you notice about what is happening in each of those problems? You're also going to want to think about the size of the fraction. We could see in this top one here that 2/3 and 2/3 are the same size. Down here we have 3/4 and 3/4, but then we have 2/5 and 2/7. So then we're going to be thinking about, well, which of these fractions is bigger, 2/5 or 2/7? And how does knowing that information help us decide which one is going to be greater than or less than? And then to finish this off, you are going to be working on number 5, which is a word problem using the table and the chart over here on the side. What I would like to see you do is partner up with somebody that you can work with and go over your answers and help make any of the corrections now that you know how to do your order of operations correctly with these problems. And then I'm going to get ready and record your next video lesson for you. Hope you guys had a great day.